Hi, I'm Mondo Saito from Keio University in Japan. I'm glad to be here today. Today, I'd like to talk about high-resolution time-of-flight measurement with narrow-band hot ultrasonic transducers. First, I will talk about the background of this research. My motivation comes from my sports experience. I'm a sailor and want to build a support system to improve my sailing skill. The support system needs a lot of anemometers to analyze wind on the sea. But the anemometers is too expensive to use a lot. So I tried to make anemometers using commercial off-the-shelf components, which is called COTS for cutting costs. Next, I introduce type of anemometers. These are two major types of anemometers, a cup anemometers and ultrasonic anemometers. Cup anemometers measure the wind speed by counting cup's rotation. And ultrasonic anemometers measure the wind speed by observing the change of ultrasonic time of flight. The time flight is called TOF, and the ultrasonic TOF will change when the wind blows. I expected to use anemometers on the sea, so I choose ultrasonic anemometers because it's tough. Our challenge is measuring accurate TOF using COTS ultrasonic transducers for cutting costs. When we can measure the ultrasonic accurate TOF, we can achieve the accurate wind speed measurement. However, there is a problem using COTS ultrasonic transducers. The problem is that COTS ultrasonic transducers cannot use existing TOF measurement method. The existing TOF measurement method is the cross correlation using the chirp signal. A chirp is a signal which changes frequency with time. And chirp needs frequency bandwidth. Existing transducers have a wide bandwidth, but COTS transducers have no enough bandwidth to change frequency. So COTS transducers cannot generate a chirp signal. Then we need to propose a new method to measure the TOF using COTS ultrasonic transducers. Next, I will introduce two proposals to measure the accurate ultrasonic TOF using COTS ultrasonic transducers. The first proposal is TOF measurement by using replica signal. It can eliminate the measurement errors caused by the mechanical characteristics of ultrasonic transducers. The second proposal is changing the phase of transmitted signals. It can improve the resistance to disturbance. These two proposals make it possible to measure the reliable ultrasonic TOF. The first proposal is about cross-correlation technique. To measure the ultrasonic TOF, existing TOF measurement method cross-correlates the transmitted signal with the received signal. In our proposal method, we use additional microphone. We call the received signal from additional microphone as replica signal. And we cross-correlate replica signal with the received signal. By doing this, we can get more accurate ultrasonic TOF. Uh, by doing this, we can get more accurate ultrasonic TOF than using the existing method. You will understand this technique after observing the difference between three types of signal waveforms. These graphs show three types of signal waveforms. Left figure shows transmitted signal waveform, and right figure shows replica signal waveform and the received waveform signal. We transmitted 40 kHz for 6 cycles, but the received signal waveform shows more than 6 cycles of fluctuation. The difference between transmitted signal waveform and received signal waveform comes from the mechanical characteristic of ultrasonic transducers. The cross correlation between the transmitted signal waveform and received signal waveform should show a poor time accuracy because two waveforms are so different. But if we replace transmitted signal waveform with waveform replica, the TOF accuracy will expectedly improve. The second proposal is about improving the resistance to disturbance. We can improve resistance to disturbance if the cross-correlated waveforms have a complexity. In the existing method, using chop signal make it possible to increase waveform complexity. But code transducers cannot generate chop signal. So we change the transmitted signal phase to increase waveform complexity. This figure shows what the phase changing of transmitted signal is. You can observe a phase changing point in the middle of right figure's waveform. By changing the transmitted signal phase, we can generate an amplitude drop point in the middle of received waveforms. It can possible to increase waveform complexity without using wide bandwidth. This technique uses phase changing, not frequency changing. So Quartz narrow band transducers can use this technique. Next, I will talk about experiments and evaluation. We set the distance 26 centimeters between two microphones. And we can easily to change distance in this experience environment. The contribution of two proposals is evaluated by measuring the TOF and comparison with the theoretical value, which is calculated from temperature and set distance. We did two experiments to evaluate two proposals. The TOF measurement with waveform replica and the changing the phase of transmitted signal. The first proposal is about cross-correlation technique with replica signal. In this experiment, we can evaluate the proposal by comparison with theoretical value and measured TOF using transmitted waveform and waveform replica. This figure shows that the TOF measurement with the replica signal significantly reduced the error from 25.5% to 0.3%. The second proposal is about improving the resistance to disturbance by changing transmitted signal's phase. The left one shows the cross-correlation output by using the transmitted signal, and the right one shows the cross-correlation output by using the transmitted signal, which is changed phase. These figures show the difference of cross-correlation output between using phase-changing method or not. We can measure the ultrasonic TOF between two microphones by checking the maximum time of amplitude. If the difference of cross-correlation output is large, the TOF measurement error will decrease, so it can improve the resistance to disturbance. We can observe a distinct difference of cross-correlation output after changing the transmitted signal's phase. This is our conclusion. The TOF measurement by using replica achieved less than 0.3% error rate comparing to theoretical value. And changing the phase of transmitted signal improved the resistance to disturbance. Thank you.